In this video we want to look at what's called transformations of the graphs. In other words, what happens when the equation from y equals sine x is changed to a different equation by adding or subtracting numbers or various other things. So the first thing that can happen is we can get a number added or subtracted onto the end of our equation. So as you can see from this picture, I've drawn the graph of y equals sine x. That's the red graph here. That's the original y equals sine x. Then I've drawn the graph of y equals sine x plus 2, that's the blue one, and y equals sine x minus 3 is the green one. So what we want to see is if we can tell just from looking at the equation what's going to happen to the graph. And as you can see, the graph has been sort of lifted up and moved. So the original one started at 0, and then the one where 2 is getting added on starts at 2, and the one where 3 is getting taken away starts at minus 3. So in other words, the size of the graph stays the same, and the slope of it stays the same. The only thing that changes is kind of its starting point. So what happens is whenever there's a number added or subtracted onto the end of an equation, that moves the graph up. And this is the same for the cosine graph as well. All these examples will be with sine, but they're exactly the same as cosine. So it would be a good idea when you're going through this video to maybe use Desmos at the same time and plot the graphs yourself, and even try changing some of the numbers and changing it to cosine to see what happens. In this picture you can see I've still got my original red y equals sine x graph, but this time the adding and subtracting part is inside the bracket as part of the function. So whereas before, if you were working it out, you would pick a value for x to be, say if x was 90, you would have done sine of 90, worked it out, and then added 1 on. Whereas this one here, the 90 has to get 60 taken away from it first before it's evaluated with sine. So that would really work out to be the sine of 30. So again, what we really want to be able to do is predict from the equation what's going to happen to the graph. So let's have a look. So the blue one is the sine x minus 61. And as you can see, the red one, originally it starts at 0 here, but now the blue one has been shifted along and it starts at 60. And the green one, again, originally starts at 0, but now the green one, which is sine x plus 30, starts at minus 30. So what happens here is the graph is getting moved sideways, side to side. However, it moves in the opposite way to what you might think. So whereas you might think that x minus 60 means the graph moves back this way, 60, it doesn't. It actually moves this way if it's a minus number. So it's the opposite to what you think. So the graph that was x minus 60 up here actually got moved 60 in this direction. So it'll finish at 420 now, because it'll be 60 more than 360. The proper name for this little angle in the bracket is called the phase angle. In this example, we want to look at what happens when there's a number multiplying the function outside it. So again, got the original red sine x one. This time the blue one is 2 sine x and the green one is 5 sine x. So what's the difference then? Well, the red one only still goes up to 1 and down to minus 1. That's the maximum and minimum. Whereas the blue one, the maximum is 2 and the minimum is minus 2, and it was 2 sine x. And on the green one, the maximum's 5, the minimum's minus 5, and it was 5 sine x. So basically putting a number in front here changes what the graph goes up to. So instead of it going up to 1 as the maximum, it goes up to 5. So what this actually changes is the amplitude of the graph. Remember we said the amplitude is how high the graph is from the x-axis. The distance, it's halfway the distance between the maximum or minimum. So the amplitude of sine x is just 1, because the distance between the x-axis and the top of the graph is 1. On the blue one, the amplitude is 2, and on the green one, the amplitude is 5. On this next one, we're looking at what happens if the number you're multiplying is actually inside the bracket again. So the red one's the original, the blue one is sine of 2x. So when sine of 2x, what's happened is we seem to have more of the curves here. So sine x starts here and finishes at 360, and it goes up to the top, crosses the axis, down to the bottom, and back up to the axis. If you look at the blue one, it's going up to the top, down to the minimum, and it's done the full sine revolution by the time we get to 180 degrees. And then it does another full sine revolution within 360. So we're actually getting two sine graphs in 360 degrees instead of one. And that's exactly what this number in front here does. If we look at this one, y equals sine 5x, what we've got is, we've got up and down and up. So there's one revolution there, just after 60 degrees. That's actually 72 degrees, that number. Then up, down, up, 2, up, down, up, 3, 4, 5. So we've got 5 revolutions because it's sine 5x. So what this changes is, this changes the period of the graph. A normal sine graph, the red one, has a period of 360 degrees because it takes 360 degrees to do the full revolution. This green one has a period of 72 degrees because there's 5 of them within 360. So if we do 360 divided by 5, it means it's only taken 72 degrees to do one revolution. So to get the period of the graph, you want to know how many degrees it takes to do one revolution, and the easiest way to do that is to divide 360 by whatever the number is in front over here. So in this first example it would have been 2, so it would have had a period of 180, and in the second example it would have been 5. In this last one, we just want to have a look at what happens if there's a minus in front of the sine x or cos x or tan x. And what happens is the graph actually gets flipped, and the x-axis acts like a line of symmetry. So you can see here the original graph, the red one, is now, instead of going up first, it now goes down first. And because they're drawn on top of each other, they make quite a nice pattern, a nice symmetric pattern, and you can see the x-axis is the line of symmetry down that. So if you've got the graph of sine x, but it's been, instead of going up first and down, it goes down first then up, it does the opposite. It's been flipped vertically in the x-axis. So the x-axis has been like a line of symmetry. And what that means is that there's been a minus in front of your equation here. And for sine x, it doesn't actually make a difference if the minus is inside the x either, because a minus being inside the function and where the x is will give you a horizontal flip, which will mean the y-axis is the line of symmetry. But because sine repeats itself over and over again, what actually happens is the graph doesn't change. You still get this this effect here. So anything to do with a minus, the graph has been flipped.